Hello all and welcome to video classes by Conor Institutes. Today we will be discussing the last question which we haven't discussed yet. So let's see what is that question first. How should we get the frequency for each class? So we have seen what is meant by class interval, what is the raw data, how we need to organize that. Right? So now we'll understand how we have to get that frequency in each class intervals. So what is this frequency means? So frequency is nothing but the repetition of observation from the raw data in particular of a class interval. Let's say for example 0 to 10 is my class interval. Okay? 10 to 20 is another class interval, and we have raw data. For example, 2, 5, 8, 10, 12, 17, 7, 22. Now, frequency is nothing but I need to understand how many observations are going to fit in this class interval. So, I will start collecting that data from the raw data so that I can make that frequency, how many number of observations are going to be observed under this class interval, right? So, let's go on doing that. So, 1 comes under this, yes, so 1, next 5 comes, 8 is also 1, 10, this we will discuss, okay? Next, 12 doesn't come because 12 is greater than 10. Next number is 7. So, how many observations did we find here? 1, 2, 3 and 4. So, frequency is 4. So, now frequency is nothing but the repetition of the observation in a particular class interval. So, you can see here in this class interval, in this range, you can see that these are the 4 numbers which have been observed frequently. So that's the reason what we have done. We have grouped these numbers under this class interval as a 4 under the frequency. Right? Next, let's see. 10. If you remember the exclusive method and the inclusive method formulas, or the way we carry out how these observations are being classified under the class intervals, right? So 10, when the number 10, here also you can see the class, lower class limit of this class and the upper class limit of this class, you have 10, right? So the rule says that you need to exclude if that number is a upper class limit, right? So that's the reason this 10, the observation or the raw data which we have, this 10 we are not considering in this class interval, whereas we are going to consider that 10 under this class interval is because the number 10 which we have here is the lower class limit of this class interval, right? Whereas in this you can see it's upper class limit, but the rule says that if that is the number which is the upper class limit, then we are not going to consider this, we are excluding this. So that's the reason 9 is the only number which we will be considering. So 10, if you get something like this, then that 10 number will be considered in the next class. So we considered 10 here in this class, 12 also comes in this class interval, 17 also comes in this class interval. So how many observations did we get? 1, 2, 3. So here the frequency becomes 3. So this is how frequency we calculate or we summarize in the class interval. So I hope you have understood what the frequency means, right? So let's move further. So in simple terms, what they are talking about is frequency of an observation means how many times that observation occurs in the raw data. So that's what we have seen here, right? So when we have a raw data, we have observations, right? Consider 50 students. If we are talking about 50 students behavior or the nature, how many marks they have scored in any of the subjects, right? So now what we have done is 50 students is our data, and each student has scored different marks, right? So what we will do is, depending on the class interval, the upper limit and the lower limit, we try to consider all those data which fits into that class interval. So that's what we call it as the frequency. Frequency is nothing but the number of times that the observations are repeated, right? So if you observe the examples which they have given in your textbook, if you observe, they have given a example wherein the students have scored marks in any of the subject. So they say that's what we have discussed, right? 1 to 10, 10 to 20. So this goes on till 90 to 100. Why? Because 100 is the maximum marks. We cannot score beyond this. And 0 is the minimum marks. We cannot score anything less than 0, right? So this class interval talks about how many observations we have in this class interval, and the same follows for the other class intervals also. So I have shown the example before, right? 1, 5, 8, 7. How did we categorize them? Is nothing but the range, the upper limit and the lower limit. We know that lower limit is 0 and the upper limit is 10. So those observations which are going to fall in these numbers, we are going to make a group of that. So that's the frequency or the number of repetition of that observation. So next we have, how do we find the class frequency by tally marking? Let's say the same example, 1, 5, 8, 10, 12, 17, 7 and 22. Okay, so this is our raw data. Now we need to mark the tally marking. How are we going to mark this tally marking? If you remember, or if you have played Antakshari in your childhood days, or you still enjoy to play that game, or some other game like a quiz which will be conducted in your schools or colleges, what usually the one who will be standing near the scoreboard, or one who will be counting on the score, how does those people count the score? It's nothing but like this, right? If a group earns 1 point, then we mark it like this. If in the second round, if the same group earns 3 points, then we add 3 more lines like this to that line, the before line which we have drawn. And the same group, if it scores 2 more marks in the next round, then what we do? We make it 5 and then we add 1 more line like this, right? Do you remember this kind? So that's nothing but the tally marking. But now how are we supposed to do that in this example? Is nothing but, in this range, the upper limit and the lower limit we already know. So in this class interval, what are those observations, number of observations from the raw data? We will start counting them. So 1 fits in this class interval, so we will make 1 mark. Next 5 also fits in this class interval, so that's the second. 8 also fits in this, then that's the third mark. 10, we know that, right? That doesn't fit in this class interval, so we will leave that. 12 doesn't fit, 17 doesn't fit here. Next is the 7. So we have 7, which is being marked as the fourth tally mark. So this is how we calculate the tally mark. Next we'll understand for the second class interval. So 10 we will be considering in this, so I will mark 1 tally mark here. 12 will be considered here, 17 will be be considered here. 22 will be considered in this class interval. So this is how we will be marking the tally mark. Now let's understand how if it is more than 5 or more than 10. Let's say I want to mark a tally mark of 18. 18 is nothing but it's not a number. There are 18 number of observation in which in the same class interval they have been repeatedly occurred. Okay. So from in the 70 to 80 class interval, this is an example. Okay. In this class interval we have got 18 as a frequency. This 18 is a number when we are talking about a frequency. But when you are talking about the raw data, right? So is this 18 a number in that raw data? No, right? We are talking about the 18 different numbers which are being observed by us in the observation. That's the raw data which we have. So this 18 is the 18 students observation, we also can call it. So how are we supposed to mark tally marking for this? It's very easy, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, 11, 12, 13, 14, 15, 16, 17, 18. That's it. We got 18 as a tally marking. So this is how we calculate the tally marking for each of the class interval by looking at the observations we have. So in the next class we will be discussing more on the loss of information and frequency distribution with the unequal class. So whatever we have understood in this section or maybe in the previous session, if you observe the class interval, you can see there we have equal classes. Right? 0 to 10, 10 to 20. You can see that the class interval is 10 for each class interval. Right? So that's the reason we call it as the equal class interval. So in the next class, we will be talking about more on the unequal class distribution. See you all in the next video class.